Amir. I'm so happy to be with you here to share this this as an introduction session about this course, which will be held in next month through BIA. My name is Jamal Amir. I'm a petroleum engineer, graduated from Syria in 1996. I worked for different international companies. Shell in Syria, then I worked for ADCO in Abu Dhabi for several years, then I moved to Iraq, where I'm still working now for Majnoon oil field in Basra. This course is very important course for everybody who is working as in production or an operation of wellhead, even for as surface companies such as wire lines companies or well intervention companies, or for operation companies. This course will describe the main components of Christmas tree and wellhead, how the wellhead is installed and the Christmas tree is installed, what is the problem which we faced during the life of well, or if the condition of production condition changes, and what is the effect of this changes on the Christmas tree or wellhead. As I told you, this course will be as this session will be as an introduction for this course. So I'll go quickly through all topics which will be discussed in details and deeply during the 5 days course, which will be held in September or next month, October. I think 11 or 12, I'm not sure the date of this course. So I am I'm authorized instructor by IWCF for well intervention. Also, I'm authorized instructor by IWCF for drilling well control. Course topics or contents we'll talk about wellhead equipment, Christmas tree components, functions and design principles. Wellhead Christmas tree control and safety valves. We will talk in details about safety valves, downhole safety valves, subsurface safety, surface safety valves, also annular safety valve, wellhead types and application, analyst pressure monitoring, wellhead and Christmas tree integrity. Same, we'll talk about this two. This same actually this two points. Same point. We'll talk about it about well barriers and well integrity. Also maintenance of Christmas tree and inspection and maintenance of at the end of this session. We see this is this photo. We see this photo here. This summarize all components of wellhead and the Christmas tree. We know all wells are drilled on stages: surface stage, intermediate stage, and production stage. So each stage will has its own casing, and this casing will create between the second casing or the casing and tubing will create an analyst. So this all casing will end here at the wellhead. We called it wellhead. So wellhead is an interconnection between the casings, different type of casings, casing strings, and Christmas tree. So we see here casing, all kind of all casing. We see this is the tubing production This is the white one is tubing, production tubing. The yellow one is the production casing. Here the analyst between, or the analyst between both tubular is called analyst A, between tubing, production tubing, and production casing. Then we see intermediate casings, and we see surface casing and conductor. So all these are in here. We called surface casing. Here we have here's the wellhead. So all casing will end up to the wellhead. Then we see here, see the white one is continue. The white one is the production tubing is continue up to Christmas tree here. Here we have the Christmas tree started. I'm sorry. So we have here, we see this ring, we see this is the ring, this is the flange, is the interconnection between the tubing head, between tubing head and Christmas tree. So, so we see here, this is a tubing gasket, the flange. So here we see also different type of valves. Master valve for Christmas tree, we have lower master valve. This we see master valve here. Lower master valve, we have upper master valve, we have kill valve. Here it is not clear, but it's focused only on the wellhead and different kind of casings and tubing. As you know, the production industry of oil and gas is go through different steps. First step is the exploration. What that mean? Exploration is to define or find the potential traps that could have oil or gas. So this is the first stage by exploration. Then will come as drilling, as either exploration drill if it's a new area or virgin area with no wells were drilled in that area. We call it exploration well. Our development well, if we have offset well or we have many wells are drilled before. So drilling is the next stage after exploration. So drilling, then completion the well. To complete the well, either if the well is natural flowing well or artificial lift, or so the completion will different depending on the well. So because natural producing well is different from artificial lift, either ESP or sucker rod pump. So the completion will complete the well. This completion will not focus here in this course in completion. We'll talk mainly on Christmas tree and wellhead. Then the production after completion, then we have to put the well in production after doing perforation and stimulation or stimulation to enhance to the production of the well. The construction. So the well here, as we see, same as I mentioned before. We have conductor, we have surface casing, we have intermediate casing, we have casing spool, we have production casings, we have tubing, head spool. So here, as I said, here we have conductors, and we have the casing, surface casing, we have intermediate casing, and we have production casing. The summary of construction, it will here, as we see from this table, the hole size and the casing size, which more fit to that bit size we called it, or hole size or bit size, then the casing size and casing name. So we see here open hole 30 inch, then we have casing size 26, conductor open hole 23, we have this either 20 inch or 18.58 surface casing, Then we have 17 inch. Then we have 1338 intermediate casing, and we have production casing 958 and production liner. If the plan in the will is to include 7-inch production liner. As we see here from the photo, the wellhead is divided to 3 parts. Section here, this first section, section B, and C, D is the Christmas tree here. So here we see here this is the flange. Here this is the first flange, which is separate between the Christmas tree and wellhead. So this parts from here, we call the section A, casing head with landing base. This landing base plate, we call this landing base plate here. Then this we call it casing head. Then also we have casing spool. This is casing head. Here it accommodates the intermediate casing or surface casing. The second one is accommodates the intermediate casing, and here it accommodates the tubing hanger. So all this one we call it section C tubing spool, section B casing spool, section A is casing and landing base plate. Then here we have the Christmas tree. It's some wrong concept, or some people think that the wellhead is the Christmas tree. This is a wrong definition. Christmas tree is different from wellhead. This wellhead from here and down, while here Christmas tree start up from this flange. We have lower master valve, upper master valve. This just, and we have here swap valve. We have here tubing production or flowing valve or wing valve for production, and we have other side should be this photo not completed here. From this other side here we have kill line. We will see it here. It's same photo. Flow here we just here we mentioned here the flow wing valve. Here wing valve, we call it wing valve for production, and here wing valve for kill. So if we need to perform killing operation before going for intervention well, we use this valve. We called it kill wing valve, swap valve. And here tree cap and gauge. This tree cap also very important here, and this swap valve is used during well intervention. This cap, from experience, most of the aged wells, this cap is stuck, cannot be open, and it's required more handling and more efforts to release it when there is a wireline job or intervention job to be done on the well. What is the function of the wellhead? We'll talk about it in details in our course. Here also different kind and the classification of wellhead. We have producing well, sweet or sour. We have all kind of artificial well here, enhanced oil recovery, other types of wells. So here this table or this diagram show different type of wells. For artificial lift, we see here second rod pump, ESP, electrical submersible pump, progressive cavity pump, gas lift, plunger lift, hydraulic pump, velocity string. So your injection, if we have injections, CO2 injection or gas injection or water injection wells. Okay, this classification of wells. For wellhead components, casing head, we call it casing head, then casing hanger. Casing head will accommodate the casing hanger. Then we have casing spool. If we have second casing, it will be run in the well. We have Analyst seals. This seals is very important. Seal because if the wellhead seals failed, then we will notice that Analyst A pressure or Analyst B pressure, so we'll see Analyst A increased, and some that we'll have some the problem will come as pressure in the well. So sorry, not in the Analyst A or in Analyst B. So if we bleed even if we bleed off the pressure from the Analyst A, this pressure will build up again if these seals are failed. So we called it sustained Analyst pressure. So this required depending on the well age, depending on the mass of the well, depending on the many factors. So we have to take decision. So this will we have to rectify this problem and define exact source of gas which is coming to Analyst A. Here, tubing head spool, we have tubing head spool, tubing hanger. Tubing head spool will accommodate tubing hanger, tubing adapter also. Just different photos of casing head housing. Casing head housing, I said this is the first part of the tubing head that will be welded or installed in the surface casing, in the first casing. Either we have threaded bottom, threaded or welded or slip bottom. Sometimes we combine threaded, then apply welding operation. As we see here, they do welding the first part of casing housing, of the casing head housing, we called it. Here, explanation about casing head housing. We'll go through it in details in our course. This is different. This is the part of casing head housing. As we see here, the casing head housing. Here we have test board. So to confirm our seal is holding pressure. Bottom preparation is slip-on welding. Here, depending on the weldings, will be connected to the casing by welding. Also, we have here this is a groove or shoulder. We call it shoulder. This shoulder we call the load shoulder because the casing hanger will stop here or at this shoulder. So this will hold the casing weight of the well. So it's very important here to install it very properly and correctly, because all further steps of well constructions, tubing will depend on this casing head housing. So in our course, we will talk about in details what is the function, how to install it by welding procedure, also testing pressure. We'll talk about it in details. Here, casing hanger, here we see the casing hanger. The casing hanger are the devices that allow casing to be set in the well bore during the drilling phase. So casing hanger, as you said, suspend the casing load and transfer casing weight, centralize casing, provide primary seal. This is the primary seal in the casing analyst. Here we call it the casing hanger. So we see this casing hanger is holding the casing here. We call this casing hanger. This is called slip casing hanger. We have two kinds of casing hanger. We have slip and mandrel. We talk about them in details, inshallah, in our course. You see here is how the casing hanger hold the casing. This is a mandrel. As we said, we have two types of casing hanger. We have this mandrel type. This is a mandrel type, and we have the slip type casing. Also, we'll talk about installation, how to install each of them in our course. So now we're talking about the another part of wellhead, which we call casing head spool. This first section is completed here. Then we talk the second part, or second is we called it the casing head spool. What is the purpose of goods? What is a casing head spool, and what is the purpose of it? So it's depending on the casing program for the well. There can be one or more casing spool, and they perform the following function. So allow for suspension of next casing string, so they accommodate the next strings of casing. Mainly, this is the main function of the casing head spool. This casing head spool, and we have here lockdown screw. What is the function of this? To prevent the vertical movement of the casing due to expansion or due to production effects of the well, and after putting the well in surface. We have here groove, gasket. We have this is gasket groove. We will talk about gaskets and rings and flanges. We call it ABI flanges as ABI because it's not allowed to use another gaskets. So here we call groove. Gasket will installed here. Upper pole. We have here loading shoulder as we casing hanger will stop here on, and we have here outlet to monitor the pressure. If we have analyst pressure to monitor pressure here, we have flanges, we have test port, all this. All this slide will be explained in our course in details. In our course here, last part of our wellhead is tubing head spool. The tubing head spool, we see the tubing head spool with the part here. We have lockdown screw, we have pole, gasket. This is upper flange, we call it upper flange because this flange will connect it to the Christmas tree flange. This flange will connect it to the last casing head spool. Casing head spool, which we talk just casing head spool. Yes. Outlet to monitor pressures. Test port to apply the test pressure test and confirm that seals are holding pressure okay. We don't have any that seal is not failed. We have here same ring gasket. So we see here this tubing head. We have here both seal. This is the same photo here. We'll talk about function in detail. Same photo for tubing hanger. See here with tubing hanger is this part we call the tubing hanger. This yellow, light yellow, light green. This will hold the tubing production, tubing, and here we have lockdown screw to prevent movement, vertical movement. Here we have seals. We have annular seals. Profile here, back pressure valve here to install. We have here because when we want to do some repair on the Christmas tree, and that we need to insert two plug or more than. So we can it's easy to set here plug. We call it back pressure valve. And we have this tubing string. This tubing hanger is holding the tubing string with tubing housing. the final Christmas tree, and case it will be like that. This is the Christmas tree. It will come from here, from this flange. Then we have here tubing head housing. Here, say casing head housing, We have two casings and two casing head housing, and we have tubing head housing. Christmas tree here start from this flange. Christmas tree, we have the second part of our course. It will talk about Christmas tree. What is a Christmas tree? What is the function of Christmas tree? Different types of valves of Christmas tree. So we have here lower master valve, we have upper master valve. Regarding the lower master valve is hand operated master valve and should not be continuously operated. This valve is only operated in emergency cases where all other valves are failed. So this valve is not normal, not a routine operation. If we want to go to do some maintenance on the Christmas tree, replace the choke valve, we should not close the lower master valve. This valve, as I told, it's only in emergency cases because this is the last. It is the last defense line or the last barrier that on the wellhead that can used in emergency cases. Because if we use this valve, maybe it will erode it or will get some passing for frequent using. So this valve we call it only in lower master valve. Only we use it during an emergency cases. We have here the upper master valve. Sometimes either it is hand operated or hydraulic operated. This valve hydraulic operated in some company. We can see this hydraulic operated. We can open it or close it remotely. And this valve also, some valves are designed in a way that it have the feature of our capability to cut the wire line in case if we have problem in the during wire line. So sometimes this line has this valve, the upper master valve is designed in the way so it can cut the wire line. This is the cross, or here we have kill wing valve. As I told, we use this valve in killing operation before doing well intervention jobs. If the well is required to be killed, so we use this valve either for circulation, either we use it for reverse circulation or direct circulation, or forward circulation. Here we have a wing valve. Also, it's hydraulic operated, and we have the choke valve. We talk about the choke. We have two different type of choke. We have fixed choke and adjustable choke. The fixed choke, if we want to replace it, or the instruction came from headquarters to increase the production of the well, and if this choke is fixed, the beam or the inside the choke is, we call it beam. So we need to replace the beam to increase and put another beam with bigger diameter, so the well can produce more. Either in reverse, if it's required to reduce the production, also we need to shut down the well and open the flange from here, from this flange, and replace the internal part of the in the choke of the choke. So while if the choke, if it's adjustable, we can immediately change the choke. Here we can adjustable choke, so can be adjustable hand by hand or also remotely. Some wells also we have the choke valve can be operated remotely. So here we have the swap valve. The swap valve also should be closed after we finish. This valve is used only in cases where we have wireline job or well intervention job. So also this valve is required to be closed. So to if in normal cases, this valve should be closed. So to avoid damage of this valve, because if this valve damage, again we have problem when we want to dismantled to remove the cap for wireline operation. This is in brief detail of the Christmas tree functions and components. Christmas tree. This also, I think this is everything here about the Christmas tree. We have different type of Christmas tree. Either it's we'll see either it's block or composite. Composite with this kind of Christmas tree, we call it composite because we see flanges here. This flange is flanges connected each valve to the Christmas tree. So here composite. While if it's block solid, we don't have this flanges. We have metal, one piece of metal only. We don't have like this more flanges because flanges with gasket, it is a potential source of leak. Either even when we use the same gasket many times, so it's potential source of leak. And if any leak started in one flange here and action didn't taken immediately, this leak will become more worse because it will, after some period of time, it will create some kind of corrosion on the internal face of the flanges. So either how much you can tight more the bolts, you cannot fix this leak until you require to replace whole valve or choke. As I told you, this is composite type, so we see many flanges here, while here we see solid block type. We don't see this many flanges. We use this type of Christmas tree in high pressure well. I have to go quickly to cover other part of our wells. Okay, Christmas. This I talk about. Here we have we call this fixed. We see this is the beam is fixed. When we want to change the choke, we need to take off this beam and change it with a suitable diameter. Adjustable. You can here, as we see from this handle, we can adjustable the choke opening quickly without shutdown of the well. So also we have different type of choke we talk about in details in our course. Multiple choke, we have here beams, fixed plug, well control. Also we have control panel, well control panel. As this is the well control panel. What is the purpose of this control panel? We talk in details in our course. This just as an idea about this equipment. This we call it wellhead control panel. This as we see here, gauges and push buttons. We see here, and here accumulator. We have pump also from outside. Sorry, other side of the panel. This valve, this panel, or this equipment is used to operate the hydraulic valves on the Christmas tree, either the downhole safety valve or the choke valve, if it's choke valve or upper master valve, if they are hydraulic operated. This will get their pressure, hydraulic pressure or hydraulic oil pressure from this panel. You see this drawing. We talk about subsurface safety valve. We have two types of subsurface safety valve. We have surface safety downhole safety valves are installed mainly for the emergency, only for the emergency cases. So downhole, and this type are fail safe. What does that mean? Fail safe closed. If the hydraulic pressure, they are opened by hydraulic pressure. If this pressure lost, if we lost the hydraulic pressure, which is pushing the subsurface safety valve flapper or bowl to open, then the spring will close the well again, the flapper or the bowl. We see here the landing nipple to accommodate subsurface safety valve here. This is the control line, as we see here. So this is the subsurface safety valve at around 150 to 100 feet, depending on the company policy. We called, as I told, we have two types of subsurface safety valve. We call we called it here we have subsurface controls. Subsurface control, subsurface safety valves. This is the downhole. This is two type of categories, and we have surface control, subsurface safety valve. So this is subsurface. So the control of how to operate the well is from downhole, not from the surface. While we called it subsurface controlled subsurface safety valves. Either it's mainly due to by flow of the well and velocity of the flow. This it will close the well or open the if the velocity of the flow increase the resistance of the spring, which opening the valve, the valve will close. We have the other side. The other type is we call it surface controlled subsurface safety valve. So we control the subsurface safety valve from surface by hydraulic oil. Subsurface safety valve, also we have two types for subsurface safety valve, either tubing retrievable subsurface safety valve or wireline retrievable subsurface safety valve. We see in our course. This is we called it subsurface controlled subsurface safety valve. So this is here bobbit type closure. This type here it's open, while when it's closed it became like that, no flow. So this is the spring is now open, closed here. This pushing, and we see the spring here. We see the spaces between spring here. It's open. This is closed. We have two type of subsurface controlled subsurface safety valve. Ambient. We have two type of this valve. Ambient pressure control. Here we have the subsurface safety valve, surface controlled subsurface safety valve. This valve is controlled from the subsurface by hydraulic line through the control line, hydraulic pressure through the control line. Here we wire line safety valve. Here tubing retrievable safety valve. So for this kind of surface control subsurface safety valve, either we can be replaced or installed by wireline, or we cannot only by retrievable of tubing. We see here this part here, this control line, hydraulic pressure. We have here control line also. We have backing, we have piston, spring and flapper. When this pressure is applied, it will push the spring and keep the flapper is open. If the hydraulic line or the hydraulic pressure is lost, this spring will close. Also, we have each one of these either wireline retrievable subsurface safety valve or tubing retrievable subsurface safety valve. Each one has disadvantage and advantages of this. We will see them in our course. This wireline subsurface surface control subsurface safety valve. Here, this is a landing nipple. Here, this is a valve. The valve will be landed here in this landing nipple, we call it, as we see here. And so we see wireline surface valve set in safety valve landing nipple, as we see here. While we see here, it is tubing retrievable surface valve. As we have two types for the mechanism, we have flapper or ball. Also, the second type, we have analyst safety valve. Analyst safety valve, this, as we see from this part, this really mainly is used in when we have gas injection. As you know, the gas injection or gas injection in the analyst or artificial lift, what we call by gas lift methods. When we produce the oil by gas lift methods, the pressure in the analyst will be high, so it is required to install this type of we call it analyst safety valve for gas lift. As we see here, the gas is injected in the analyst. So we see this the yellow one, it's open. In case if some accident happened on the Christmas tree or the point where we inject the gas and the gas is released to the surface, so this valve will close like that. So as we see this the yellow one, blue one is closed and gas is prevented going off to atmosphere. We see here the flapper of subsurface safety valve, how it's open. We have this is sleeve. This sleeve is pushed by spring to keep the flapper is open in open position. The spring, sleeve. We have also what is a daily routine operations or checks of the wellhead. What pressure we have to observe, parameters, pressure, temperature, analysis pressures. If there any visual inspection is also is very important to check if there is any leak, or also if there also another important point if we have any changes in the Christmas tree height. One example of my experience. One time I was visiting a Christmas tree to take reading every day, as that will in a program to visit that will every 2 days or something. I saw that Christmas tree it is slip down or slide down by 2 or 4 centimeters. So it's very important also to notice this point. If the Christmas tree height changed, also if we have vibrations on the Christmas tree, vibration due to production, of course. The connections between Christmas trees, valves, and tubing head, this should be API connection. We have 3 types. Either we called it studded. We see this studded connection. We see here flanged connection. We see this flange. It will come a flange and put here with gaskets. So gasket will be for all. And we have this clamp one also, clamped connection. Clamped connection is morely seen in BOB, as we see here. This is a gasket. This 2 flange here. In between, we should put gasket. As I thought, this gasket should be used only for one time, because this here we have elastic part. If we use it, it will seal. If there is any small spaces or crack, very small crack, it will provide good sealing, but it's second time it just cannot give the same sealing as first time usage. So this ABI recommendation only to use the gasket for one time. We have gasket, we have two type of gasket, and as we see here, two type ABI 6B, and this is flange at for working pressure 2000 to 5000 psi, and ABI 6BX we called it 10,000 or 10,000 to 20,000 psi. Each type of this flange take its type, different type of gasket. So for 6B it take we call it the ring, ABI ring, ABI type R and RX, while for 6BX only BX. X means, what does mean by X? We see here this hole, we see hole, so this self-energized, that will give more sealing. Also, we'll talk about differences between both in details. What is the difference between 6B and 6BX? So also we'll talk about analyst pressure. What is analyst pressure? As I mentioned here, okay. Analyst pressure is very important to monitor analyst pressure in the wellhead. Most wells have three analysts. We call analyst A, analyst B, and analyst C. Analyst A is between the tubing and between the production tubing and the production casing, while analyst B is between casing. Analyst C is between also surface casing and intermediate casing. This monitoring the pressure in this analyst is very important, because it gives us an indication of what the status of the well, either from the wellhead or downhole situation of the well. If we have any corrosion, or if we have bad cement, and if we have corrosion, or if we have pinhole. So this if we see if any one of these analyses have a certain value of pressure that exceeds the recommended value by the company, so investigation should be start immediately to identify and find the source of gas or this source of pressure in this analysis. As it could be from the Christmas tree, and it could be from the wellhead, from wellhead seals, either from neck seals or cavity seals, or from downhole. Downhole, it could be here from the reservoir. Here we have some bad cementing activity jobs, and cementing is not good. We have corrosion in the casing, so we have some communication between reservoir and the analysis. Or it could be here from backer immediately. If this backer we have some leak or not set properly, it could give some source, so that formation fluid would go from here, from this area, to the analyst. So we call it here, we call this, if this pressure is bleed off and build up again within quickly, so we called it sustained analyst pressure. And this sustained analyst pressure, if it should not exceed the one value we called it MASP here in the surface in the surface. So the MASP is if the analyst pressure value, maybe for A, increase the MASP value, then we have, it could affect the formation show here in the casing show here, or it could collapse the tubing, or could burst the production casing. So here, as I told, we have to identify the source of pressure immediately to take the correct actions, either from Christmas tree or by doing corrosion logging or acoustic, or called acoustic logging, to find the bonding strings between the casing and cement. All this logging have to be done before determining or during the investigation of the source of the pressure in the analyst. Also very important to know how to calculate the mass value. We'll talk, we will explain it, and we'll see how to calculate it in our course. We'll talk about well integrity and barriers. What is the definition of well integrity as per NORSOC D10? It is application of technical, operational, and organization solution to reduce the risk of uncontrolled release of formation fluid through the life cycle of the well. Why we talk about integrity here? Because the Christmas tree is a part of this well integrity. So as I told, integrity, it will take care of the well during the life cycle of the well. If we have any problem in the Christmas tree or wellhead, this seals in the wellhead. So it allow pressure to build up in the analyst, and it could, because if the pressure in analyst C or B increased, it could be burst to atmospheric. So it's the situation, it will become more worse. So it's very important to know what is the well integrity and what is the purpose of well integrity. As we see this Christmas tree here, so here we talk about integrity is include life cycle of the well. It starts from design, construct, operate, maintain, abandon. The integrity should be considered in all stages of the life cycle of the well. As we see here, even during the operation of the well, even the well, if newly recently put in the handed over from production to operation after drilling and the perforation is completed, then and will put in production for the first time. As you know, in the analyst we have we call it completion fluid in the analyst. After drilling, we keep this analyst is full of completion fluid. And if we start producing the well, there will be some thermal expansion for this fluid in the analyst. If we didn't bleed off this increasing in the pressure, it could cause, as we see here, burst. As we see here, some burst due to thermal expansion. See how much this burst happened. Surface casing failed at 16 feet. Because what? Because the pressure increased up to 7,700 psi after or during startup of the well. Because the well, it's newly started, and it was it's cold. And when we have high fluid, then new fluid came with high temperature, it's caused thermal expansion for the fluid, the completion fluid in the analyst. Also, we have other failures cases. We have this case. What is here? Well integrity team will discuss all these points in details in our course. What is the barrier system? As we said, we have two type of barriers: primary barrier and secondary barriers. The primary barrier is first equipment or tools that come in contact with the formation fluid. As we see here, this is primary. It's just the blue one is the primary barriers. Secondary barrier is when the first one is failed. The primary one, barrier is failed. In the secondary barrier, it comes here. It's the red one. We call this secondary barrier. We'll talk about in details about them. Here, barrier definitions. What is the difference between independent barrier, dependent barrier, also a barrier element and barrier envelope. All this we'll talk about them in our course. How to test the barrier and what type of barriers. We have mechanicals, we have fluid barriers. So all this we'll talk about them in details in our course. Also, we have closed barriers and closable barrier. We will see the difference between them. Mechanical barriers, hydrostatic barriers, other barriers. This is examples of barriers. Barrier envelope. What is it? We'll see definition. What is definitions and examples of barrier envelopes. See, this is barrier envelope here. Barrier envelope. Let's see. As you know, for barrier envelope, for drilling, we need to have during drilling we need to have two barriers. Which one is first, the primary one is hydrostatic pressure. Second one is BOB. For well intervention, we need three barriers. As we see, BOB, lubricator, stuffing box. For so well intervention, we need three barriers. Here we see we have some question in our about barriers. Barrier testing. We talk about barrier testing also. Question. We have many questions about well barriers. So you can understand more about well barriers. By the way, this question is taken from IWCF well control exams for well interventions. How to select the Christmas tree and maintenance of the Christmas tree. Corrosion, what is seal and gaskets, formation changes and fluid, preventive maintenance, what we'll do for Christmas tree. We have periodic maintenance, and we have which is done by either 3 monthly or 6 monthly to check the Christmas tree visual inspection, or to greasing, cleaning, to check if there are any leaks. So this is kind of periodic maintenance, planned maintenance, called PM maintenance. This is also, we have visual inspection, as we told, lubrication, to grease the valves, to avoid this greasing should be done should be done after any job, mainly if we have acid job, or we have to grease these valves again, so to avoid bad effect of the grease on the valve internal. So the valve, it could be corroded if we didn't clean it or grease it after acid job. It will get stuck in open position or closed in positions. So it's make the situation more hard and more difficult and required more efforts to resolve it. We have function test and pressure of Christmas tree and cavity test. We will do it. In flow test, here we have this kind also to determine non-destructive testing to determine if we have any unseen cracks on the metals of a Christmas tree. Here we see the methods. Here we called it here. So this type of examinations, methods of non-destructive examination. Here we use ultrasonic and also liquid vent rate testing. We'll talk in details about them in our course. This is the methods of how to perform the vent rating testing, liquid vent rate testing. Here we see how it's work. Here we have a crack. When we put this vent rate liquid, the liquid will come inside here, and then we remove. Here we clean the surface and put a new light, we call it deliver powder. It will show if we have crack in the Christmas tree or in the metal of the wellhead. Here, this is the main topic of our course, our session. These topics will explain in details also in our Christmas tree course next month. Thank you very much.